I've spent the past 12 months and over $100,000 of my own money building the world's first AI Valorant coach named TrainingArc. But every time I think I've cracked the code on using AI to analyze Valorant gameplay, I run into walls faster than Wile E. Coyote. So it led me to stop and think, what if brute forcing AI isn't the best approach? What if there's an easier solution that's not as technologically demanding? And what if that solution lies in an ancient technology that's been hiding in plain sight for the past 25 years? Computer vision has come a long way. Today, models can detect enemies, hit confirmation, and movement with decent accuracy. But as we built TrainingArc, we've ran into a problem. Computer vision just isn't precise enough for what we want to measure. It can guess when you shot or move, but it's still a guess. So I started asking a few questions. Is there a better way to capture what's actually happening in a gunfight? Could we log inputs directly, your mouse movements, clicks, and key presses, and pair that with the video? And could we do it without hooking into Valorant and getting banned, using Windows native functions instead? I'd always assumed that doing too much locally on a computer would reduce performance, and as Valorant players we never want to lose performance. But what if there is no cost? So I put on my vibe coding hat, opened a blank VS Code file, and decided to find out. I opened Visual Studio Code with the Codex extension and started to plan this out. And what I made the mistake of before is planning something out and letting it do everything without understanding any of it. So the first step I did was to ask, what is your framework or your approach in terms of making this work? And it gave me a bunch of points. And from there, I realized I needed to understand all of these points so that if I needed to debug or troubleshoot later, I'd actually have a way of figuring it out. So the plan was to use a Windows function called raw input. That's how we'd capture your mouse movements, clicks, and key presses in real time. But there's a catch. Raw input used this way is basically a keylogger, and if you know what that can do, that's bad. You can't just run a program that silently records people's inputs. That's how you end up in malware territory. So before we could even get to data capture, we needed a safe way for players to start and stop recording themselves. That meant building a small GUI, a graphical user interface with a visible recording window, a start-stop button, and an I acknowledge I'm recording checkbox. Once that was working, there was still another problem, custom key bindings. Because some people have some pretty weird key binds, but more on that in a bit. Now that we can capture the raw inputs, the next question is, well, where does all that data go? We store it in a buffer, basically a small chunk of memory that acts like a reusable container. It's kind of like if you wanted some water, it's nice to just have a glass rather than having to make a custom glass every time you wanted to drink. So we also created this container, this buffer, and we put all the data in there. The heart of it is timing. Every event needs 2 clocks. UTC, that's the universal time. Today, right now, it is 1:22 p.m. Pacific time. And QPC, or the query performance counter, your PC's internal stopwatch that gives us frame-accurate precision. To keep them aligned, we wrote a small helper that links QPC's local samples to UTC. That way, every single event carries both a universal timestamp and an exact local offset, so we know precisely when things happen. At the end of each flush, we've got clean, structured data, event, type, payload, UTC, frame accurate timing, all neatly packed into a JSON file and becomes tidy timestamp data ready for analysis. Once I got the pipeline working, the next challenge was obvious. How do we sync it with the video? Because the input logger runs separately from the video recording. None of this data matters unless we can line it up perfectly with your recorded video. This problem is actually really similar to video production. You've probably seen the clapperboard, the clack sound they use to sync audio and video on set. We're doing the same thing here. Players already record their gameplay however they want. Shadowplay, OBS, Insights.gg, whatever the software is. There's no reason for us to reinvent video recording. We just need a way to synchronize our input data with that footage. So we had 2 options. Add a visual overlay like a flash or use audio. I didn't want to inject anything into the game that could even remotely risk violating Riot's terms of service around in-game overlays. So we went with audio. When you start the input logger, it plays a tiny beep, something that shows up in both the input timeline and the video's audio track. That one sound gives us a perfect sync point. Once we have that beep, we can offset every event in the data and know exactly how it lines up with the video. I tested it, refined it, and it worked beautifully. Once the framework was in place, it was time to actually build it. The hardest part, surprisingly, was getting the input commands to register correctly, especially when you have to tell the difference between left control and right control. And yeah, I know it's a little weird. I use left control for jump and space for crouch. So getting these custom bindings to work took a little while. But at that point, I had no idea if any of it would actually work or if all of this was just going to be theoretical. So I recorded a short test video, turned on our new shiny input logging app, and used the beep sync we built earlier to line up the data with the footage. Then I ran the offset and rendered a new version, an overlay showing my actual key presses and mouse inputs in real time. And the best part, it matched. Every key, every click perfectly synced to the video. But here's where I ran into a problem. At first glance, it looked perfect. Every click, every movement lined up exactly with the footage. But when I went through it frame by frame, something was off. Each shot was landing about 50 milliseconds late. 50 milliseconds doesn't sound huge, but in Valorant, that's enough to throw off our measurements for reaction time or crosshair placement. And the confusing part, we didn't know why. It could be that Windows Raw Input reports slightly after the game engine. It could be Valorant's internal timing, or maybe it's something specific to my setup, a 9800X3D running Windows 11. We'll need to do more testing with more user input to figure this out completely. But whatever the cause, it meant our frame perfect sync wasn't actually frame perfect, and that's something we'll need to investigate deeper if we want this to scale reliably across different systems. But once I applied a manual 50 millisecond offset, the data clicked. My key logging lined up within plus minus 1 frame, about 16 milliseconds at 60 FPS, and that's effectively frame perfect. That result gave me real confidence that this approach can deliver the granularity and accuracy we need, precise enough to analyze crosshair placement and gunfight timing to give the insight we're really looking for. So this is where it all comes together. I fired up the logger, loaded into a game and started recording, and it worked. Not only did it capture every input with frame level precision, it also opened the door to something even cooler. We can now analyze mouse aiming patterns directly. Imagine running this on a pro player's VOD, seeing exactly how they move their mouse in a gunfight, how efficient their corrections are, how stable their crosshair stays. That's the kind of data we've never been able to see before. While I was running, I also wanted to test performance because that's pretty important too. And so I watched Task Manager on my second monitor while I was playing. 0% CPU and around 50 to 75 megabytes of RAM. Just the buffer before writing to disk. So effectively, the input logging is free. There's no impact on gameplay, no lag, and no dropped frames. And that was huge. High precision, zero performance hit. It's working exactly the way we hope. The next step is to bake this into the Windows app so it ships with the product. That's what Sam, my developer, will be working on next. For me, this was the moment it all clicked. This system gives us the granularity and confidence to finally analyze crosshair placement, reaction time, and mechanical efficiency at a professional level. It's super cool, super exciting, and honestly, it makes me believe more than ever that we can map and truly break down what great aim actually looks like. If you're interested in learning more, hit the link below and subscribe for more updates. And if you want to join the beta and have Training Arc improve your gunfights at the lowest price it will ever be, there's a link below in the description. If you want to see a demo of the Training Arc beta in action, then watch this video next.